Welcome back to the shop, guys. Getting kind of excited about being able to thread on the mini lathe. There's been quite a few projects where I've had to thread like a 1/2 inch, and that's a lot of force on this poor lathe. Usually you kind of get it started and you got to take it out and put it in the vise and finish it off. So in order to get ready for threading, especially the precision vise that's on its way from Rhode Island, 2 issues I need to fix here, and this video is those issues, so you'll see how I solve them. Pretty easy to identify the problem with this little widget. Can't believe they didn't put a washer underneath here. That would have been nice, but problem is when this thing is at an angle, just the tip of this guy is hitting the lead screw for the feed. So it's real easy. Well, that coupled with, I just measured it, the lead screw has the teeth on it or whatever that this guy is just barely touching. But the width of this from here to here is 32 thousandths. 0.032. That's gapped right there, the 32 thousandths, because I just measured it. So, I mean, wow. It's really easy at this teeny angle for it to skip, and especially because of the trying to mesh the two together. So what I'm figuring is, because of this, and it's hitting that chip protector metal thing that's on top of the lead screw. So I got to come down further and come over. So I need to make an L kind of bracket here. Got the material for it. I just need to cut it off and then start making chips all over the place after I just cleaned up all the carpet. So I've got some dimensions drawn out here. I'm not sure exactly where this hole is yet. I'll know that more when I get this thing here and this drilled, because it'll be in the same spot. Get this mounted, and then I can kind of hold this under there and judge so that I have some adjustment that I can do and tilt. So that should solve the problem and make this thing reliable. And being horizontal, I can still see the numbers. The other thing I'll show at some point here, which is really trick, because you engage the apron and you disengage it and you move it slightly and it won't engage, and you move it slightly more and it engages. So when I have this built, I have a feeling that is the correct place to engage. That's the wrong spot. I have a feeling it's that touchy, but we'll see once I get this thing made. Just thought I'd show a little bit of this. As you can see, I've got my little chip shield up here. Keep them from flying all over the floor and me. And I am using on every pass a light coat of the oil stuff that I make with kerosene. And I'm going down about 20 thousandths. I do have a little pencil line here that I can see. You know, part of obviously doesn't have to be that accurate as far as width, but so as soon as I hit the pencil line, I'll just say, all right, that's it. And I'm real close to it right now. You can see the chips fly everywhere. Yeah, one more cut and then finishing pass. Not that I really need a finishing pass. All right, that should be almost on that pencil line. Oh. I need another pass and then finishing pass. So finishing pass, I'll just do about 2,000. Just dust it off a little bit. So that's all there is to it, guys. Probably not the best of angles, but like I said, the lighting sucks too, I'm sure. Face mill, I gotta take 24 thousandths off of it. I got the touch DRO, blue DRO, fired up. Shield goes in the way. I've already, I think I put oil on there, right? Yeah, there's, all right, great. So let the chips fly. And Z is zeroed out. So, barely taking anything off of it here. All right. Take it down 5 thousandths. There we go. So I've got 24 thousandths to go. Just dropped. Now. And I am running on the battery because I did run on the wall for some project, something I was doing, and I caught it jump. Both X and Y all of a sudden were inches off. So I'm just going to be testing this. And maybe it's the scales, maybe it's the noise in the AC power line. We'll find out. Best thing I ever bought was face mill. I think I said that already, but alright. Take it to 10 thousandths. 5, 9, whoops, 12. Oh, that's good. 12 thousandths. I probably could have taken a huge chunk off of this thing, but whatever. Hopefully you guys can see it. Maybe I'll tilt it a little bit here. And I like going this direction because the chips are flying away from me and the floor. Alright, still on 12. I guess I'll take it to 20. I've already done the other side, just cleaned up the surface, so there we go. Not much, just a very thin coat. Alright, take it to 20, 18, 19, 20. And then the last will be the 4 thousandths, and I'll be at thickness. And again, none of this stuff is that critical, it's just approximately there. Actually, for the width, I went too far. I'm 20 thousandths, 25 thousandths too skinny, but it'll work. Alright, still saying at 20, and nothing's jumping around, so y-axis still zeroed out. Yep, and looks like the x-axis is still correct too. Alright, down to 24, 2, 3 because I already took off 1 or 2 thousandths. And this will be it. Yeah, scale's holding in 23, nice. So, like I said, I'm just going to see here with the battery if anything ever jumps again. And off. Get rid of the shield and try to clean out some of the chips that are stuck to it. Oil. Put it over on the other bench. Disengage this guy. Time to deburr the edges. So, cool. Alright. Simple and easy. 5/8 end mill comes back. Go down 200 thousandths over 920 thousandths. The touch TRO, this is the beta one that Yuri sent. Rock solid off the battery. I caught it blinking a couple of times, which is normal for the older scales. It just now blinked again in the y-axis. But it stayed right on Z, X, Y, and Z. It was perfect. So I'm happy. Deburr time, and now set up, vacuum a little, clean up, and set up for drilling the holes. Thought I'd show this because this is, well, it's going to be a 1/4 inch hole, and I'm going to use that Tap Magic for aluminum, which is over here. You can see it's clear as water. And I should have put it, there's a different one of these I have where that's a lot smaller, but boy, it pours right out. Alright, well, let's go with this. Well, the chip's going to wind up hitting the camera, but I'm getting better at controlling how much goes in or gets dispensed. But it's just, I love this stuff. I'm going to use it from now on for drilling. That's just beautiful in there. I don't know if you guys can see it. Let me look in the camera here. No, you can't really see much of anything, huh? Can I move it any better? Lighting, shift the light around. Maybe that's better, I don't know. But I love it. It's great stuff. So, before the chips hit the camera, let me cut it. See, that's what I mean. It just works out. Already had a 1/2 inch collet in there. So here's the new one that I made. And I did the little trick with seating it, unseating it, seating it. I've got the bottle back there, so it'll hopefully focus on the bit. But there's the bit. I don't know how close I can get. I don't know what this is gonna look like until I see it. I am shaking. Alright, just wanted to share that. Don't you just love it when everything goes perfect and right? Unfortunately, this is not one of those times. So, there's the guy, all machined up. What I did was I screwed him in there and C-clamped this guy on. And I don't know if you can see it in the camera, and then I scratched where the hole is. It's right here, it's dead center. This should have been a lot longer. So, I mean, I just kind of banged this thing out, which is a mistake. You just can't do that. You got to do a print and stuff. But, kind of interesting thing, too. I'm looking at this going, you know, his hole, or whoever made this, is really loose. Mine's a lot tighter. And same way with the countersink here. But when you put the screw in here, it looks centered. It doesn't look like it's got a problem. And you put mine in there, because I had it hanging down, and it looks a mile off center. So I was wondering and looking at it, and realized, kind of cute trick, mine was done with an end mill, so it's an absolutely flat bottom. I'm looking at this, it's funneled. This was done with a drill bit. So when you drop the screw in, it automatically centers itself up as you tighten it down. So I'm going to start doing that. Quit using the end mill. I kind of like the looks of a nice flat, shiny bottom, but whatever. So I'll start doing that. So this is not going to make it. So what I got to do is go back to the drawing board, and that's the first thing I did was you need to do a print, Dave. So I started doing all the dimensions here, the numbers. Well, might as well bring it over here now. There's the final product. As I machined this, I was entering in the correct numbers, and these are the coordinates for that hole from this edge and this edge. And I'll double check these two with the caliper. Because what, 1925? Turn this on. where are you? 1925. Oh, 1332, close enough. Nope, I'm off. I don't know what. Then where I was, I didn't think I reset anything, so I'm going to have to figure out where that goes. But in any case, yeah, this can go away because I milled things differently. So I'm going to double check all the numbers, put it in, finalize it, and put it on the website if anybody wants to make it. I did the same thing with this guy. I had actually increased this depth, because it was very close to the metal shield on the lead screw. But I did put this guy in there and C-clamped it, and everything should be good. The original screw too is too long. Oh yeah, I was mentioning, I think I mentioned that there's three set screws for the gib, for the claw. So I made a pocket to clear them rather than using the washer like I did before. So that works nice. Shorter screw. It is funneled. I haven't even checked out. Oh yeah, see, a lot better. It centers itself up. Nice. This guy should go on here, right? Why are you not going in that hole? That was scary. Because I threaded this for the 6mm. So, and I'll actually, come on, get on there. Where's the hole? There it is. And, oh gee, I already chamfered all this. I was gonna, once I had this all right, I could figure out how to make that flush. Wow, that's it. It locked down real quick, huh? All right, well, this should fly big time. That's a lot further in than this other weird thing. So let's go over to the lathe and see what happens. All right, let's see what happens. The lighting probably isn't that hot, but let's see here. All right, so this guy goes in here, and I should have been using a ball driver because this is a pain going back and forth like this. But I'm gonna have to get a flashlight out in a minute so I can see where it is underneath. Almost there. All right, is that straight? Almost. Yep, that's straight. Isn't it even engaging? It's engaging already. Okay, so I'm gonna do the final adjustment. Hey, I'm way in there, which is perfect. Perfect. So let me loosen this up and make sure it's in there. Oh, yeah, that's gonna move on me, huh? All right. So that should fix that problem forever. Oh, I'm tilted out for some reason. I'm hitting something. Might not be right with the set screw. Oh yeah, and I was gonna see. All right, if I want to come up on the one, doesn't lock. Locks there. Doesn't lock there. Oh yeah, that's a lot of movement. I have to take it back. Locks on the one. Yeah. So you'll definitely be able to tell when to engage this thing now. I'm kind of bummed. Why is it hitting a screw? I can't see in there. There's a flashlight again. Oh, it's over here, Dave. I can almost see in there where it's hitting. I guess I can loosen it and swing it and see what's going on. That should be flush. Something else is going on then. That wants to just cock because I'm not. Yeah, it's this surface is crooked and it's making that thing walk way out. Great. Why is that surface so bad? That should have been machined nicely. Oh, come on, it's always a pain with these things. I should make some Allens where you just cut that off so that you just keep spinning. This surface is that bad, huh? Come on. Well, I should be clearing those two guys. Yeah, I can feel it. I'm clearing them. So I got the holes right. But wow, I don't know why when you clamp it. Do I have plenty of vertical movement? I'm very close. Oh, because I'm already hitting the lead screw, so that's there. Wait, I just want to make sure the screw line's right back up. Yep, falls right in there. So I am clearing it. All right, well, the problem is solved. Be interesting. I want to try some threading again and see if I can actually use that thing. So hope you guys enjoyed. Well, as you can see, the ugly wobbly dial has been replaced with something a little bit nicer, and it's rock solid. There's no skipping or anything, and I can engage the feed on any one of the dots. So let's give it a little bit of speed here. So engage, and the dots are straight up every time. And I did a test run here. Try it again. Boom, there it is. I did a test run. I've got a piece of 1/2-inch stock, and the cutter landed exactly where it's supposed to be every single time. The screw fell out of my coupling because I've got it loosened up. But all right, so I got a reliable, whatever you call it, threading indicator that stays there. So I'm thrilled with that.